Hi, I'm Caitlin Lee.
I'm Stephanie Wescott.
And our math practice 1 is make sense of the problem and persevere in solving them by us. Okay, so background information on MP1 is make sense of the problems and persevere in solving them. Mathematically proficient students start by explaining to themselves the meaning of a problem and looking for entry points to its solution. They analyze givens, constraints, relationships, and goals. They make conjectures about the form and meaning of the solution and plan a solution pathway rather than simply jumping into a solution attempt. They consider analogous problems and try special cases in simpler form of the original problem in order to gain insight into its solution. They monitor and evaluate their progress and change course if necessary. And older students might, depending on the context of the problem, transform algebraic expressions or change the viewing window on their graphing calculator to get the information they need.
Okay, for our background information on this math practice, mathematically proficient students can explain correspondences between equations, verbal descriptions, tables, and graphs, or draw diagrams of important features and relationships, graph data, and search for regularity of trends. Younger students might rely on using concrete objects or pictures to help conceptualize and solve a problem. Mathematically proficient students check their answers to problems using a different method, and they continually ask themselves, does this make sense? They can understand the approaches of others to solving complex problems and identify correspondences between different approaches. What it means: understand the problem, find a way to attack it, and work until it's done. Basically, you will find practice standard number 1 in every math problem every day. The hardest part is pushing students to solve tough problems by applying what they already know and to monitor themselves when problem solving. Own it. Give students a tough task and let them work through them. Allow wait time for yourself and your students. Work for progress and aha moments. The math becomes about the process and not about the one right answer. Lead with questions, but don't pick up a pencil. Have students make headway in the task themselves.
Okay, for our first mathematical example, we chose to relate it to a situation pretty much everyone has. In a cafeteria, 3 coffees and 4 donuts cost $10.05. In the same cafeteria, 5 coffees and 7 donuts cost $17.15. How much do you have to pay for 4 coffees and 6 donuts? Our solution uses the 3-step math practice definition. First, you understand a problem, find a way to attack it, and then work until it's done. The steps are as follows. So number 1 is let X be the price of 1 coffee and Y be the price of 1 donut. We now use 3 coffees and 4 donuts cost $10.05 to write the equation 3x plus 4y equals $10.05. For the third step, use 5 coffees and 7 donuts costs $17.50 to write the equation 5x plus 7y equals $17.15. Subtract the terms of the first equation from the terms of the second equation to obtain 2x plus 3y equals $7.10. Multiply all terms of the last equation by 2 to obtain 2x plus 3y equals $7.10. Multiply all terms of the last equation by 2 to obtain 4x plus 6y equals $14.20. That makes the solution 4 coffees and 6 donuts costs $14.20.
This is our example for the elementary level. A traditional rainbow has the colors red, orange, yellow, green, blue, and purple. How many lines do you need to draw in your rainbow so every color is used? For our solution, we use the 3-step math practice definition again. To find the number of lines you need, add up the colors, write out the equation, solve the equation. 5 lines need to be drawn in order to use all colors in the rainbow.
So for our teaching example, we used the following problem for our COP integration. There are approximately 1.5 billion acres of the Amazon rainforest. There are approximately 1.2 million acres lost to deforestation every year. What percent of the Amazon rainforest will be lost in the next 5 years if we do not make efforts to halt deforestation? What percent will be lost in 5 years if we cut the current rate of deforestation into a third of its current rate? So the process for solving this problem is as follows. First, you divide 1.2 million by 1.5 billion. You can simplify this by taking 1.2 divided by 15 because they are both whole numbers, 1.2 and 1.5. The answer is 0.0008 multiplied by 5, giving us 0.4%, the first solution. For the second question, divide 1.2 million by 3, which gives you 400,000. You can take 0.4 divided by 1,500 to simplify the numbers, or do it with all the zeros instead, and that will give you 0.026%. If you multiply this by 5 to signify the 5 years, you get 0.013%.
Students need to be prepared for learning by being able to communicate about the learning experience. They need to be able to ask for help when they need it. They should know the following basic learning phrases or sentences. I don't understand. Would you please explain that to me? What information do I need to remember? Is that important for the test? And to prepare for our rainforest example, we help students prepare for the problem and make them understand. We will establish when we would like questions to be asked during the lesson and how. We will also establish a partner system for when the students are working on their work after the lesson. Finally, we will prepare to give many examples.
So for our building background information, teachers can build background connections by making purposeful connections to prior learning, by teaching the most important vocabulary, and by trying to connect the content to something the student may have already experienced. So the following is background information for our example. This is also related to number 1 of the math practice definition, understand the problem. We will explain what deforestation is, review how to calculate simple percentages, explain how to convert large problems into small ones, and define necessary vocabulary. So for the comprehensible input and vocabulary, teachers should make assignments clear by using vocabulary students can understand and by providing a variety of instructional experiences including total physical response. Teachers use hand gestures, facial expressions, and whole body movement to illustrate concept or vocabulary words. Students emulate the movements. Also, use of manipulatives and web resources are important to use in many lessons. The following is the comprehensive input and vocab for our example. This is also related to number 1 of the math practice definition, understand the problem. The Amazon rainforest is the vast basin of the Amazon River in northern South America. It remains largely unpopulated and undeveloped, especially in the interior. An acre is a measure of land area in the U.S. and Britain that equals 4,840 square yards, about 4,047 square meters. Deforestation is the act or result of cutting down or burning all the trees in the area, and halt means to put a stop to.
Okay, for our teaching example and incorporating the COP model, students can benefit from knowing specific strategies to use to increase understanding, including the following. Provide ample opportunities for students to use learning strategies. Learning strategies should be taught through explicit instruction. You want students to develop independence and self-monitoring. Also have a consistent use of scaffolding techniques throughout the lesson. Introduce a new concept using a lot of scaffolding and decrease support as time goes on. Restate a student's response or use think alouds. It is also important to use a variety of question types, including those that promote higher level thinking. This is related to number 2 of the math practice definition. Find a way to attack it.
So interactions and motivations. Student-to-teacher and student-to-student interactions can be enhanced through the following. Sufficient wait time. In most classrooms, students are typically given less than 1 second to respond to a question posed by a teacher. Increasing the wait time from 3 to 7 seconds results in an increase in the length of student responses, the number of unsolicited responses, the frequency of student questions, the number of responses from less capable children, and student-to-student interactions. Group consensus is another method of interaction and motivation. The teacher asks specific review questions. Students seated in groups of 4 or 5 write their answers and share them with other group members. Groups must discuss until they reach consensus. The group answer is submitted to a teacher. Points can be scored if the teacher chooses to make the review competitive. Find your partner is another strategy that can be used. Each student is given a vocabulary card with either a definition or a term written on it. Students are asked to find the matching card. Then students share with the class the pairs they have made. How we can relate this to our example, this relates to number 2, find a way to attack the problem. We can give students multiple strategies to solve the problem. We can base these attacks on the various types of learning styles, like auditory, kinesthetic, etc. It helps to encourage students to use different strategies to see how they can solve problems most effectively. For example, visual learners could use the coloring page to signify the number of trees cut down.
Okay, for our teaching example incorporating the SIOP model, practice and application, students need hands-on materials, manipulatives, opportunities to practice and to apply concepts learned, and opportunities to integrate reading, writing, speaking, and listening skills. Graphic organizers are a good example. Bingo is also a favorite among many students. Computer program applications are a good method, and partner and group integrated games. How can we incorporate this into our example? This aspect relates to number 3, work until it is done. A fun example for visual learners would be a grid-like coloring page with various trees, coloring the deforested parts brown and the preserved parts green. A project for mathematically minded learners could be to create a bar or line graph showing the rate of deforestation. Physical learners could play a game where one group represents the trees, another represents the loggers, and you have to time them to see who can move from the forest to the logging camps at a certain rate. Using the computer to research rates of deforestation in other parts of the world may also be an option.
So for our review and assessment, comprehensive and deliberate review of key and area concepts and vocabulary will enable students to demonstrate mastery. Examples shown below. Table discussion groups. Students discuss answers to questions similar to those that will be on the assessment, and a simultaneous roundtable activity. Students help each other review by writing their team number on a paper that is passed from one student to the next. Each student adds a fact about a given concept and passes it on to the next writer. Teams are given a short time frame to complete the task. Don't forget the importance of final assessments to make sure students have mastered the concept. So methods for review or assessment of our topic, and this relates to number 3, work until it is done. Students can use the peer teaching method to attempt to solve problems among themselves before coming to the teacher for help. Students will evaluate this knowledge and teachers will evaluate this knowledge and how it is handled between students. An overall rubric detailing student expectations over the concept will help assess project progress. Pre-testing and post-testing are also valuable tools to monitor student progress. Final, cumulative assessment should allow students to show their knowledge in more ways than one prescribed method, demonstrating their individual mastery.
Okay, these are the resources we found for this math practice. There are many different resources. The first link talks about 8 components of sheltered instruction, with examples and strategies on how to use them. The second link provides lesson plans using the COP model for teachers free of charge. The third link provides many different printable or online free math activities for students at all grade levels. And these are our references.